Hello again. This is the visual tools session of the Clojure Data Science Special. And in this session, we will have brief introductions to a few visual tools which have been created in Clojure and Clojure script. And since we are quite a few people who are going to present, it would be nice if any of you could try to make it a little less than 10 minutes, like 8 minutes if you could, but 10 minutes would be just fine. And after all introductions, we'll have a discussion. So we'll begin with Maurício, who could make it today. And thank you so much for making it today, although you were very busy. So Maurício.
Okay, hi. So let me share my screen here. Hope I get the right project. Yeah. Okay, so I'm going to show, can you see my screen, right?
Yes.
Yep.
Okay, wonderful. So I'm going to show a little bit about Chlorine and the visualizations library that I am doing. It's not really a library, it's more like a plugin. And this is a very improvised presentation. So I am reusing one that I used with Spock that was from my Prolog environment. So, okay, the first thing is that Chlorine is not about data science. It's not a data science project. It never was, but it grew a little bit closer to the ideas of visualizations. So it started with a socket REPL, and after a little while, an REPL package for Clojure and for the Atom editor. So it was developed as an alternative to Clover and ProtoREPL, and it's only for it's for Atom editor and for Visual Studio Code right now. The Visual Studio Code right now it's called Clover, not Chlorine. But anyway, some of the tools that I'm going to show right now do not work yet on Clover, and I am quite working around some limitations, so it's not really that far on the VS Code. But on Atom, they work 100% fine. Okay, so what was the idea? It began with a socket REPL just to program in Clojure, but then I thought, well, maybe I could allow people to customize how they want to render the code and the visualization and the data structure. So we already had a reagent on the Chlorine project, so why not? And that's where we are today. So this presentation here, it's inside Atom, and it is indeed a custom visualization already. So how does this thing work? So let me show a little bit here. If I evaluate a code that ends up with HTML and a valid regent hiccup, and I evaluate with the eval interactive command, it will try to evaluate that hiccup as an element in my editor. So Atom and also VS Code, they are mostly like browsers. VS Code is more limited than that, but Atom is a full-blown browser. So we can run like any HTML and anything here. So for example, I can run something that have a title. So now I get like a beautiful bold text and not only a plain text. So everything that can work like with regent can work here. The second thing that I can do, I defined this magic state atom that is a regent atom. So I can deref that atom and get the result. If I try to evaluate that, it will fail. Why? State atom is not something that exists in this context, because this is not valid Clojure code. But if I quote, then it's a valid Clojure code, right? So now I can interactive render it, and you can see that it does bind the state to the state atom as an atom. So if I want to like make interactions, I can do a little regent trick here, like on click, prevent default, and then swap the state atom to increment that. And now I have a simple counter 100% in Clojure script inside the editor. There's no repo interaction yet. Oh, well, there is one, right? The first eval call. So this is evaluating in a Clojure repo to generate this data structure. That is a regent one. And then it's captured to the Atom editor, and now everything is over the Atom side without Clojure script with SCI and so on and so forth. SCI, the work build project. But I can do like repo interactions. So for example, if I define a value here, increment value, like 2, for example, I'm going to copy the result of that. And instead of doing onClick on regent side, I am going to do onClick on the Clojure side. So here I have the increment value as a variable, as a full qualified symbol. The state is the current state, and this is always quoted because this is something that will be called on the repo side. So what will happen here is onClick is bound to a virtual callback that will call this function here, fn state, and so on and so forth, on the Clojure side, on the repo, and the result will be bound to the state. So now if I interactive evaluate that, I have like being incremented 2 by 2. Now if I change this to 3 and evaluate again, I am incrementing in 3. So what does it have to do with like data science and visualization tools? That these visualizations can be as complex as you want. So for example, here I have one called chessboard that generates something quite complicated. So I'm not going to show everything here.
By the way, it will be good to finish in 3 minutes, okay, if you could. Yeah.
So, right. So this will render a chessboard, and you can also evaluate something even more complex, like the movements that this piece can do. Like, so for in this position, only 1 and 2 pieces can move here. Or you can bind into any Node.js library. So for example, in this case, I am binding with the dgraph. It's a .graphviz library. So I can like evaluate something that will be captured to this node library, and then it will be rendered as a graphviz. So this is the parts where things get complicated, and I want a little bit of help on that. I am seeing lots of wonderful libraries like Hanami and others appearing in the Clojure script world, but so far Chlorine only can handle Node.js libraries. So we can like export with a library to Node.js and do a translation layer and then using inside Chlorine, but it was quite complicated. So the next steps is I'm trying to do and I'm trying to figure out is how to bind this Clojure script libraries so I can do that in Chlorine. Chlorine does have a wonderful and also complicated limitation. I can't expect the library, the visualization library, to be in the class path all the time. So it must be bound to the Chlorine, but also in a way that doesn't like bloat the whole plugin. So that's are the next challenges, and that's all. Thank you.
Beautiful. Thank you so much, Maurício. Yeah, and let us move to Jon Anthony. If you could, Jon, if it is comfortable.
Okay.
Or we could do another one if you prefer to do it later.
Yeah, maybe.
Yeah, no worries. Yeah, maybe Chris, is it comfortable if you wish?
Actually, sorry, I need a few minutes before I can start, but yeah, I'd be happy to go next if that works.
Oh, maybe I was talking about the wrong Chris.
Oh, okay. I didn't think I was next on the schedule, but this is Chris Small.
Oh, yeah. So maybe the earlier Chris would be good. Yeah, thank you, Chris Small.
Got it. Yeah, no problem. Thanks.
Yeah, I can go now.
Perfect. Thank you.
So let me share my screen. Okay, can everyone see?
Yes.
Okay, cool. Thank you. Yeah, so my name is Chris B. And I recently gave a talk at London Clojure about Portal. So I'm not gonna cover as much as I did there, but I'm gonna talk a little bit about Portal, which is a project I've been working on, which is in the same space that a lot of these tools are in. Yeah, so my problem was I would have big data structures, and I think that's the other things that this is more focused on the data structures and not necessarily the like graphing and charting and understanding like numbers. It's more about like understanding data structures. But yeah, so let me just dive into the Portal like UI and API. There's this Portal function called Portal API open, and you just call it, and you should get back a window that opens up that is connected to your runtime, and it lets you evaluate. It lets you tap stuff to it. I kind of have it set up to also tap whatever I last evaluated. So right, this evaluation right here is a var called dev. And that's why this is showing up here in my Portal window, because I said I wanted to tap out all my vars. So, but yeah, what I want to focus on more than how you interact with Portal is like what data and what viewers it supports. So let me just, usually when I'm developing Portal, I'll like play with this data structure consistently when I'm like iterating, because it has all the interesting data types that I care about in Portal. So it has like some basic data types like lists. What I'm doing here is I'm pressing E to expand and contract it. So that's the other thing you can do. I kind of went over this in the talk, but yeah, to interact with data, you can click it, select it, and you can expand it. But yeah, Portal supports lists, all the core Clojure data types. It can kind of recognize certain strings. Let's see, it knows specific Clojure types like vars, tagged types. It knows about records, right? So not only does it know that it's a Clojure map, but that it has a custom type for it, right? So, and then you can actually click on that. I think my computer's lagging a little bit. But yeah, in any case, let me do that, right? So what I'm doing here is I'm selecting the type for this record, and then I can, since I have that type in my hand, I can call bean or I can call datafy. What I did there is and this is going to be a whirlwind tour, so if I'm going a little bit fast, sorry. But yeah, I'm opening the command prompt right here, and I'm doing it with Control J, and then here are all the functions that I can use against the value I had selected. So I can datafy that value. And so I've just datafied the class for that record. And I can see all of the different fields that the datafy would give me for that class. So if I go back, here's an atom. They're kind of cool because you can deref them, right? Let's see, what else can I do? Clojure supports, or sorry, not Clojure, Portal supports also calling meta on things, right? So if the thing has metadata, you can grab it by calling meta. It does have support for Vega, Vega like proper and Vega Lite. So here's like a chart, which underneath it is essentially a list of values, a list of maps that have X and Y. So let's go to the tree viewer. Well, what I'm doing here, by the way, is I'm swapping the view at the bottom left. So this is like a demo of all the things you can potentially do with Portal. Yeah, you can view the same piece of data in different ways. So here I'm viewing it as a table, but let's say I want to view it as a line chart or as a scatter plot or as a histogram, right? So it supports those. And these, I think, are specifically matching structures that Portal knows about and projecting them onto like Vega types, and then using the Vega viewer to render them. Whereas down here, let me just close this. Here's a more direct Vega support, right? Like this data structure for this force-directed graph example is going to be much larger and more like, oh, this is exactly Vega, right? So you can pipe Vega directly to the Vega viewers. So let me collapse that. Let's see. So there's Vega support. Let me go back. There are, it supports Datafy and Nav specifically, right? So if I implemented the protocol Clojure core protocols Nav on a data structure, then I'll invoke this function when you click onto one of these, or when you try to navigate into them. So like if I go to show stories, this should take me to, and what that did right there is it's using the Nav protocol to call out to Hacker News and leverage their API, which lets you kind of access all of Hacker News by HTTP endpoints, right? So here I'm looking at one of the stories on Hacker News, right? So that's Datafy Nav. I don't know how much time I have left, so.
4 minutes.
4 minutes? Okay. I'm just throwing everything I can at you guys. I'm sorry. But let's see. There's also a hiccup viewer. And what that does is it takes data structures that look like hiccup, right? So here is a vector containing a keyword at the front, right? A div, and then its children. And those, again, are more hiccup nodes. What's really cool, though, is I kind of transform. This is hiccup plus a little bit extra because it supports portal viewers. So you can see there's a recursion here where here's the normal HTML hiccup, and then you can also go back into portal land by using a portal portal viewer itself. So if I go back to the inspector, sorry, if I go back to the hiccup viewer, and again, just the bottom left, you can view the hiccup viewer, and then it'll render the data as HTML. But in turn, like inside of it, you can also, I'm trying to click that. There we go. I can then go back into portal land and have more data, and then it could do, so it's like kind of recursive, which is what HTML is, right? It's recursive. It supports binary information. It'll assume that it's a picture, but you can also view it as like a hex dump. That's sometimes useful if you have binary data. Let me go back to the inspector. What else? We have dates. So one of the things I commonly use is relative time, because I'll see a date time and I'm like, when was that? So I guess this data structure or that timestamp was sampled 37 minutes ago. So that's kind of neat. Exceptions, you can datafy them. And this is something that's implemented in Clojure Core. And then I'll recognize the datification of it and render it in a different way. I'm still exploring different ways to render exceptions because I think there's kind of like an art to rendering exceptions. This is kind of my current iteration. So that's kind of cool. Let's see. There's also, so strings are we tend to like hide data in sometimes because we need to pass them through systems, right? So this is a string of CSV. So I can just say, oh yeah, I know that's a CSV string. So what that did is it parsed that CSV into its actual data structure form. And then because now I have a data structure, I can say, okay, portal, render that as a table. So what I did here is I turned this CSV string into a data structure, and then I turned that data structure, or I viewed that data structure in a different way. So I'll commonly do this, especially with like log data, where like sometimes things are serialized and then serialized and serialized. So I'll keep digging in deeper to get more at the data of it. And then like I don't have to worry about big gross log strings, right? I don't know if you guys have to deal with that, but yeah, it supports other strings like markdown. So here is, right, here's let me go to the text viewer first. So here's like a big dump, and this is the portal readme, right? And I don't want to render it as text or as a string. I want to render it as an actual markdown document. And so here it is. Oh, and I guess one last thing. I think this would be the end of it. But you can set the viewer in metadata. So what you'll see is that this hiccup guy has metadata that's portal viewer default, portal viewer hiccup. So it's saying I want the default viewer for this data structure. Even though there's a myriad of ways to interpret it, I want you to interpret it by default as hiccup, which is why down here you can see that hiccups is the top instead of these other two viewers. So that's kind of like a whirlwind tour of all the things that portal can do. There's a more elaboration on this in the README, and more document improvements coming in the future. But I think that's pretty much it. So
fantastic. Thank you so much.
Yeah.
Oh wow. Yeah, so much to learn. Yeah, so I guess if it works, then Vlad, you could be like the natural continuation of that, right?
Oh, yes, I can do that. Let me start with sharing the screen. So I made reveal. This is its homepage. And as you can see, it's sort of a REPL output pane. And this was like an idea of what reveal is for a long time. But the problem that I was trying to solve is how to get closer to the data in the virtual machine. Because when I was going from Java to Clojure, like I was feeling this pain of being too detached, like there is a wall between me and the code I type, the code I see like in the editor and type checking, and between what is actually executed. So when I moved to Clojure, that wall was teared down, and I felt that it's getting much more easier for me to develop when I'm closer to the data. But I was thinking that maybe it's possible to go even more closer and to have like a REPL output that is explorable as data. So that's what I did. And when I came up with the name, I got a little bit sidetracked into making it an actual REPL, but it doesn't have to be that way. And like just a couple of days ago, I released a new update that brought it closer to the original vision I had, which is sort of an overlay over your IDE or text editor that works from the GVM, so you can use whatever editor you want. It's like as long as it can send forms to a REPL. That means that a reveal is available in your editor. And I can show you a couple of examples of what I've been doing with it. So this is my work project. Let me restart the atomic connection just in case. So here is this project I worked at in my work, and I use reveal stickers. These are small windows on top of my IDE that have their own place. Like I can close them and then reopen them, and they will be back there. And one of the things I think I was lacking when programming is having some sort of a leave views of stuff that changes because the state is complexity and it's better to be aware of it. So for example, we use mount. It's a library for like a component managing of lifecycle of different mutable components like web servers and connections. And what I did, like here you can see, like in the REPL, I can start it or stop it. But I also created a short, like a very small sticker that shows its exact state and what exactly, like what components are started or stopped. And I think it's important to keep things both simple and easy. So it's like the idea was to not require like special event handlers or anything from the user, but like just the most minimum stuff that I should ask for. And here, for example, like the whole definition of this window is that I'm watching an atom of what components are currently running in the state, and I have a title. And what else? Let me show you another example. this is more data science related. So I've been exploring stock market, and here you can see a Vega spec. Yeah, can you do it? Oh, it's quite big. Let me show you. So I just pressed the shortcut that shows like opened a new window with the explorer of this Vega data structure. So I can view it as a table, and maybe view that as a table, and that. Okay, so there are lots of data points, and all of that is sort of available from the IDE, just because like the IDE is capable of setting REPL commands, and there is like an inspect last result with just like a very, very small command. And yeah, you can do a Vega view. I blogged about it a while ago, and when I needed this. And I think what's also important when like solving visual problems is having some sort of an instant feedback. So this was also one of the areas of importance for me, and that's why I did observable views. Here, for example, you can see that I have a var with the Vega spec, which is just a data structure, because Vega is just a JSON. And I define like a window that observes it and renders it using the Vega visualizer. And
by the way, 3 minutes if you could. Thanks.
Okay, yeah, that's gonna be plenty. But what happens now is that there is a listener observing this variable, this var. So if I redefine it and use something like load price and dividends for Microsoft. Okay, so you can see that it immediately loaded the prices and showed the chart of a Microsoft. And I can iterate on the Vega data structure at the REPL and like without having to like open the window with a new rendering and checking it and closing it and opening it again. I can just keep working at the REPL and see the updates immediately. And that's what actually what I was doing here. It's like, oh, I have I have a price and dividends information, and I want to and I wonder what is like what would be the yield of me investing in Microsoft if I do dividend reinvesting, like and I made a function that does dividend reinvestment program basically, and you can see that it's a bit bigger. Oh, I probably should show it like that. Here, for example, like I can experiment with this kind of stuff and have results visible immediately. Like you see that like there is a difference between just buying and holding a stock and reinvesting dividends. But over the long time period, the difference is actually not very big. So that's an interesting thing I learned thanks to Reveal. Woohoo! That's it.
Fantastic. Yeah, and there is so much more like the extensibility of the system, and I guess that kind of applies also to the previous ones. And yeah, fantastic. So I guess it could be now Christopher Small, if it works.
Yeah, that's great. Just a second. Let me
yeah,
camera and get stuff ready here real quick. How's everyone doing this whatever time of day it is? Great. Cool. So let's see. Time is it? Okay, 9:40. All right. Let me go ahead and share screen here. All right. Cool. So how's the font on the right? Is this good?
The right is good.
Okay, great. How about the left?
It's small.
Okay, I can make it bigger. I'm not going to be looking at that too much for right now, but I thought it would just be fun to for this presentation just kind of actually just use kind of the normal sort of notebook experience instead of the slideshow stuff that I've been working on. So yeah, hi everyone. Welcome to Oz 2.0. This is the next iteration of the ideas that started under Oz 1.6.0 Alpha Star. I don't know if you've noticed, it's like 36 of these alpha releases. A chunk of those were for kind of random things, but like, and you know, Vega updates and stuff. But it's been a very long time that that Oz has been in this sort of alpha state, and the reason for that being that it was, you know, about a couple years ago that we started working on all of these kind of, you know, now people are kind of calling it like namespace as a notebook kind of functionality, but at the time, you know, I was calling it, you know, live code reloading, and for kind of a data science workflow. I hadn't quite hit the language on that, but so what this really does, and I'm kind of going backwards a little bit here. This is sort of out of the hammock time for me, because I've been thinking about how a lot of these, right, like one of the things I've been talking about lately is how Oz is kind of a Swiss Army knife, and it's got a lot of stuff that it's able to do in different settings, in different contexts, and a lot of people aren't kind of aware of all those things, which has been kind of one of the challenges, I think, with the project. But that having been said, thinking through some of these really big design challenges, given all the things that Oz is trying to do, has just meant a lot of hammock time. And I think now kind of finally at the point where I've gone through some of the major kind of design blocks that had held me up, and am now kind of making progress on all this stuff. So what Oz, there's now, I should have put this in the notes here. We can do the,
There is this sound problem where we can't hear you while you're typing.
Yeah, thank you. Yeah, I paused that. Great. So so please check out Oz. What is it? It's 2.0.0, and I just released Alpha 2 last night with a couple of minor fixes. So that's down there. Yeah. So so what this brings right now is greatly improved default fonts and styles. So this here is the computer modern font set from Knuth, which I just love. And a kind of somewhat generalized compile multi-method system for these recursive transformations, so that you can plug in a different kind of input or output to Oz, and it will sort of hook up to everything else. So you don't need to say how. If you can say how it gets translated into hiccup, then you can see how it gets translated into HTML or PDF, or, you know, different kinds of output, or the live view. Without you having to do all that work. You just say how to, it plugs into hiccup, and it kind of does the rest. It also, as far as the namespace, I didn't finish writing here, but so live watch and build. Live code in the talk. So as far as the namespace as a notebook kind of functionality goes, we're now processing comments that start with two semicolons as markdown. We render code standard out and standard error, but this can be turned off for reporting, and can talk about this a little bit more later. We're doing parallel evaluation of independent code blocks. So not just, not just running things one at a time, but only focusing on the ones that need to update, but actually within that, update model, running things in parallel when we can. And that actually, the implementation for that actually comes out pretty nicely just with core async, which was kind of fun to write. The next thing here is this kind of what is now becoming a more fundamental notion to the project. I mean, prior, like really Oz was really just about like taking Vega and kind of extensions as well, but like really thinking about like hiccup as like the main kind of document model. Everything in the system kind of compiles to and from hiccup. And that's going to be changing slightly, I think, with this new iteration here, because there's this concept of async blocks now. And this is to solve a problem where if something fails in your notebook, like the whole thing crashes, right? And you're kind of, or you just don't get any updates, and it's not ideal for development flow, right? So the async block model, what that does is it allows us to, as we're evaluating things in parallel, we can be sending each result from each block to the client as it comes in. And this just makes a huge difference as far as the responsiveness when you have just a little bit of text changing, or when you have just one component, somewhere in your data flow changing. It just makes a huge difference as far as, not having to wait for those updates to come back through. So this ended up being a little bit challenged. Again, this is where the last 2 years have been spent, is thinking about how to make this work with the API that I'd basically built for the 1.6.0 version. One of the things that, once you kind of get to this async block model, I was thinking like, well, before I came up with the async block model, I was thinking, like the difference here with some of the things we need to do is kind of move to this model where you can think about a series of changes coming in, kind of it's streaming in, right? That was kind of my initial model. But that made it sort of weird to continue to support this template function option to the build function, so that you can decide what different chunks of your kind of build output are gonna look like, as far as the template that each of the individual what I'm now calling blocks fall in. So I didn't quite know how to resolve that, and the idea of an async block, which is just a hiccup node that represents this is something that isn't here yet, but which will be here. And when I send it to a client, it will just sit there kind of waiting until I send it the thing with the corresponding block ID. And once it does, then it'll go ahead and update. So that kind of was the solution to this problem here. The next thing is failing blocks presenting stack traces. So you don't have, well, I'll just show you some of this stuff. I don't know why I'm going through this in such detail, but
3 minutes, by the way, if you could.
Yeah. As far as the reagent components go, also added API hooks for the full vegaview API. So for those of you using Oz as a reagent, set of view components, you now have the ability to stream data into visualization, or update attributes of individual datums in Viz, or control the signals. I mean, there's a lot of stuff that you can potentially do with that. So unlocks a lot of cool app potential. So yeah, please check out Oz 2.0.0 Alpha 2. And I already kind of talked about this. So here's just kind of what things look like. Again, comments to be processed as Markdown have to look like this. They have to have the two semicolons in the space. Otherwise they won't be rendered. The reason for this is that you need to be able to comment out code. And this is one problem I saw with Clerk, is that if you try to comment out some code, it thinks you're doing Markdown, and now you've got this weird blob of stuff in your prose. It's just kind of a weird experience. So this is sort of following the pattern that Marginalia established, where it has to be this very particular comment style, which is really convenient, because not only does it let you comment out code, but you can also add comments that you want to stay in the code by just using 1 colon, semicolon, or removing the space. And additionally, Markdown is indentation sensitive. And so I wanted to be very clear about like what part is that, starting piece, so that there's no confusion about how white space is going to be interpreted. So this is really cool. This was something I've been thinking about for a while. Markdown comments can have metadata. So you can attach this sort of Clojure metadata looking thing before a chunk of this Markdown comment stuff, and it will it'll merge that into the attributes. So here we can color something red just by doing this. We can also there's care been taken to make sure that if you have a single div or p tag when you parse everything, and it contains just a single item like a header or a image, that those things, instead of giving you this kind of wrapped thing, which is sort of unnecessary, it makes it hard to use this metadata syntax. We just unwrap it and give you that image so that we can merge those things in where you probably want them to go. You don't need this thing in a paragraph, right? So by the way, this is a shoe bill. They're awesome, and prove the birds are dinosaurs. So code. This is the parallel or async evaluation model. So you can see here, we get status when things change, and print out standard out, and we can even see dependencies. So you can see here, I'm defining a funny thing and then calling that funny thing down here. And I can actually click on this set of dependencies, and that'll take me back up to the top here, where we started. And you see that if I change this, it would wait the whole set of time before this went through. Okay, I guess I'm at the end of time, so let me just race through here real quick. So parallel execution, here's some demonstrations of this, 2 things running for 2 seconds that this thing depends on. And if you run it, you'll see that it just waits for 2 seconds and then finishes promptly and prints some stuff out. Error handling, this is what this looks like, right? If you try to divide by 0, you get this nice stack trace. And then what's really cool is that downstream of this, it'll show things as having been aborted if they depend on something that errored out. Multi-method support, working on making it so that it'll automatically unalias the multi-method so that you have a better reloading experience for that stuff. Old hiccup stuff is still supported, and then Vega, obviously. And and last thing, there's a great set of I'm starting on a set of like classes for styling, and this particular set will give you access to the different computer modern fonts, which I just love. Like, these fonts are just so gorgeous. I had tried to get these before when I released Oz, and I couldn't find them in kind of a web friendly mode, but I was able to this time. So there's some other stuff here, but I think we can talk about a lot of this down the road. My hope is that within like 5 months or so, that we'll be able to take this out of beta. I know that Oz has been in alpha for a long time, but this is again kind of an inflection point, because I've worked through a lot of the design challenges that I foresaw. So yeah, with that, I will say thank you.
So wonderful. Yeah, thank you so much. And now we will jump to NodeSpace. So I'll share the screen. And right, and what we have here is another of those attempts to have a notebook-like experience in our usual REPL session. And so we'll have the browser view and we'll have the editor. And NodeSpace has been a tool that was used in the last 3 years gradually in the Clojure community. And it has evolved in a few different versions. And now we look just a bit into what version 4 is trying to do. And let us begin with a demo. So you see we have some layout of our text and code and results, and the mode of interaction we're trying to achieve is to be able to just do what we do in the usual editor and REPL. So we can change the code and save, and then the view updates, and we can evaluate, and the view updates. That's it basically, right? So and yeah, we'll maybe talk about it later a bit. So yeah, and these are kind of the 2 core principles we have been following recently. One, just grow as the community needs, do whatever is needed for the current needs of the community study groups and projects. And I'm not sure if it is always successful, but at least that was a driving principle for this project. And another thing that is currently going is trying to flow with the REPL. So kind of learning from previous experiences, we try not to introduce new evaluations of code, just to listen to existing evaluations of code. And that is basically because it is hard to introduce new semantics of when and where things are evaluated. So, and that is what we see here, that we can just, just do what we do and have it updates, right? So we just do what we do. And maybe another thing to discuss is that we are looking into different ways to specify how different kinds of things should be rendered. So there is this idea of metadata attached to code, and there is an idea of metadata attached to the return value, so that the kind of visualization can be determined in runtime. And there is a certain Clojure protocol called kindness, so that certain things can just implement this protocol and this way tell the tool how they should be rendered. So for example, Java buffered image is a certain class that I want to render as an image. So I could do that using this protocol. So these ideas of kinds are part of a new library called Kindly, which is just a little thin layer that is trying to be responsible for that, for specifying how a certain kind of thing should be rendered. And, you know, NodeSpace is looking into certain time-related semantics such as closure delays and trying to embrace them in the process. Maybe we shouldn't discuss it now. Maybe just a few examples of a few things we can render: math and tables and plots and images. And currently NodeSpace uses Gorilla UI, which is part of the emerging Ping Gorilla ecosystem that Florian will talk about later, but it is not kind of up to date with the most exciting improvements in Ping Gorilla. And that's it basically. And personally, I'm very much interested in looking how to create compatibility across tools, because we are very much hoping to create many user sessions which are documented, as we have been doing, but we want to kind of standardize it in a way where we have this collection that is growing of user notebooks. And for that, in order to enjoy all the tools, we need to think, I think, about building bridges across tools. And that is what I hope we may discuss a bit later in the discussion part. So that's it for NodeSpace. And now, oh, thank you. Now, I guess, Jon Anthony, would it be good for you to talk about Saite?
Okay.
If you could, you know.
Yeah, it's okay. Yeah.
Yeah, thank you.
Let's try it at any rate. So I should share my screen here. Let's see if I can. I think this isn't the right one. Okay, can people see that?
Yeah.
Yeah, okay. So this is probably going to be the most different of all of the stuff that's discussed today. It's really, so when you install the thing and you fire it up, you can go to whatever port you set it to run on, and it'll come up like this. This is what it looks like. So if we just reload this thing, yeah, that's it. So pretty much everything here is going to be done in Saite in terms of what I show. So probably the first thing is, so what is it? It's kind of hard to say exactly what it is. It's not your typical notebook or anything like that. It's more of a, I've taken to calling it a studio for Clojure for exploring data, creating and saving visualizations, creating interactive documents and dashboards. So in a way, it's a bit like RStudio, only it has a lot more capabilities. Yeah, it's much more than a typical notebook. You have these main editors for document creation. So for example, this page here was created by this little snippet of markdown stuff over on the left. You can open and close these editors for presentations. You can use code, visualizations, markdown, LaTeX, reactive components. That's a big thing for building dashboards. It's not cellular, modal, or linear like typical notebooks. These doc body editors can be live and interactive. I'll show you an example of that. You can directly mix code, Clojure, ClojureScript R. I don't know about Python anymore. You can have multiple namespaces. You can have namespaces per tab. Okay, and these are the tabs up here in this particular document. And if you look at this thing, you can see here's the NodeSpace, the namespace here is this, I don't know how this one got this goofy namespace, but it did. But you could change that. And And you can share, or you could share the namespace cross tabs or have each one be a different namespace so you're not stepping on yourself if you're doing the same kind of data analysis and you're trying out different things, but you want to use the same name for your bars and whatnot. And then you can organize this thing, your document or whatever you want to call this. It's kind of hard to say exactly what these things are, along chapters or sections or whatever, and that's really where these tabs kind of come in. So we're actually up to 1.1 and the 1.2 is coming. It's a self-installing and updating Uberjar. So if you grab this thing, you just give it a Java and an install, or if it's already been installed previously, you can use update. If you're on the Mac or Linux, the easiest way to run the thing as the server then is to just use one of the pre-supplied scripts for running the stuff. There's 2 versions of this now because JVM 9+ requires extra switches for Neanderthal. So another thing that happens, that's a good point, is when you install this thing, it will automatically give you the MKL libraries that you need to run the uncomplicated stuff. There you go. And so, and at that point, you can then click on an upload document or in the Clojure Saite overview. But I have a bunch more here, but there's a handful that come with the thing that you can then fool around with. Or you can load a document from a URL if it's published someplace. Okay, so another thing here, let's just, in this particular spot, let's just go over here to it. It's galleries, just shows you a bunch of visualizations and stuff using Markdown and LaTeX in addition to it. So these, it just gives you a bit of a, and you could, in this particular document that comes with it, you can open this thing up and then play around. You can sort of walk through this and sort of update these things and fool around with them if you wish. Maybe that's about it for that. Let's close this up again just to show you some of the LaTeX that's available. You can do any and all of this kind of stuff. Okay, and these things can be live. You can sort of, I don't know how this is going to work here on the Mac. I always have a hard time navigating the Mac, but you can, yeah, you can do all kinds of stuff, interactions and whatnot. All of these things, all of this stuff is in large measure based on Hanami as an application building library. It's so large amounts of the capabilities in this thing are really coming from Hanami. This automatic layout of all of these, the body here, and how these things are all laid out. Each one of them is a thing called a picture frame, where you have a top, right, bottom, and left. All of this kind of stuff is how it works. And you can have, here's an example where you have, it's an empty, it doesn't have a visualization, but you can put these kinds of things together. Here's an empty where you have columnar stuff, where you have a left and right column, so you can make an entire page that looks like that. Here's one with the visualization stuck in the middle, and here's one that's up and down. But all this kind of stuff, automatic layouts and whatnot, is available. So maybe that's it for this one. Let's go over here and show a little bit about just these controls and whatnot. So you can upload a document, you can save one of them, you can grab code files, you can grab them from a URL as well. One of the things you can do that comes with it is—
It's 3 minutes, by the way, if you could.
I beg your pardon?
If you could let us have more 3 minutes.
3 minutes?
Yeah, yeah.
Okay.
Thank you.
It's virtually impossible. Maybe we should just give up right now. Yeah, so you can do all of these different things here. You can add interactive tabs. So let's just show an example. We can just automatically include some stuff and draw a picture with it. We can do some more of that. Maybe change this to let's say that and this editor stuff here works pretty much. You have your slurp and barf, and you have, it's a full-blown editor. You can configure it completely. All the keys and stuff are completely configurable. You can just dump another one of these things in, and you can keep going with this. If I don't have any time left, it's pretty hard to explain the rest of this stuff in any kind of even superficial detail. There's this quick help that sort of gives you an indication of what you can do. This stuff, again, all of these keys can be changed to however you want with a config.eden file that comes pre-configured, but then you can change them all. Let's go and take a look at a couple of quick, another example, say, of how you can have editors in the actual document body, and these editors can be live. Okay, so we can close this up here, and then we can evaluate this. So this is actually, you can just do these things, and then we can come on down and sort of give an example of it. And just sort of keep going. Same thing with this down here. So you can have editors in your document body that are live, or they can be static, just like a kind of a standard notebook cell. So that's a kind of an example of that. Let's do another example here. All of these things are just stuff that you can do. So here, this one here uses TechML. I think I have some of this already loaded, so we can just come over and do the visual. Actually, one of the things that's kind of neat is to see the, where is it here? Just sort of how the output is. Oops, I think I did the wrong thing with that. Oh, okay, I guess it worked out pretty good. So you can sort of, and then all these windows are resizable. So you can just sort of pull things over and kind of look at stuff. And this is sort of maybe somewhat interesting in terms of how you can do the pictures and images and things like that in it. You can just update these things, and you just keep kind of adding new ones if you want, and that kind of stuff. Okay, let's go and take a look at actually, let's do one other thing here before we do that. Let me show you the COVID stuff doesn't work anymore because they took down the data source. All right, so this is running a little bit here, and it shows a dashboard. So these widgets and stuff are all predefined things. They come as a sidebar, slider, single, drop down, whatnot. And if you look at what it takes to do that, you literally can just use them. So we have a slider input and a text input for the first one, and a slider input and a text input for the next one. These things, oops, looks like hard didn't work for me here. Okay. But in general, it should work. I don't know exactly why this didn't happen the way I was hoping, but
the idea is that you have
live demos. So I want to show one other thing here. Actually, a better one. I want to show an actual live thing here. All right. So this is another dashboard, and it sort of supports. One of the things that's really neat about this is it intermixes code on the client and on the server. So, okay, I guess I'm done. I don't know why it did that. So it's a little confusing to me on this. See if I can maybe do this. Okay. All right, yeah, that's a bit better. But you can see that the actual size of this stuff is pretty big. So it's 100 million reads for this thing here. So you kind of need to be able to run the data stuff on the server and then have it pass all that stuff over here to the client that does all of the actual visualization and representation and things like that. So there's a boatload more that could be discussed with this. One of the things that's going to happen is I think we're definitely going to have a presentation, a much fuller and descriptive presentation of how this thing works and what you can do with it at the January Boston Clojure meetup. And I hope actually to maybe be able to do a series of those, like one every couple of months.
Yeah, so if it is okay, let us discuss this more in the discussion part, John. Do you wish to kind of conclude, say anything before this part ends?
I think I just did.
Thank you so much, and sorry that we cannot continue more. It does deserve like a full session. And great, so maybe the last one is Florian, if you could. Florian, would you like to kind of introduce some of the Pink Gorilla ecosystem?
Of course. Let me share my screen. Can you see my screen?
Yes.
Okay, wonderful. So I'm just going to demonstrate the Goldly demo that is on Pink Gorilla GitHub. So I'm starting it with this alias, which will basically start a web server that will load some predefined bundle. This could be also compiled that would use completely different set of UI components, but that's the default. I give it a configuration, which is in a sense a routing table, and I tell it which pages it should load. So we see here it has loaded all kind of extensions that come by default, and it's loading a few Clojure namespaces that I want to load, and it will send to the browser a list of default pages. So I made this one example that this is a client-server based example. And essentially, the code I have here is interpreted in the browser by the SCI Clojure script interpreter. This is all watched dynamically, so the different pages can get changed dynamically. Where are we? So that is the part to basically just register a service that will handle requests that come from the browser. So that is the services module. You could do this also on a push interaction, and I have made a demo to push the time. So in here, I would just have a time pusher that would push any kind of data, and the pages can then show what they want to show. The interesting thing is that it's possible to use any kind of React stuff, and that works pretty nicely in this interpreted SCI Clojure script. I could include various UI components. So here is like a map component. In this case, it's showing the current position of the ISS. Well, that's this code here. I think it's quite compact for what it does. That's here a demo that would show data in HE grid, or here that's a demo that would do some stuff from with Vega visualization. Now I made some dev toolings. There is Awb99 Goldly and Modular, which are the sort of the dev tools, and then there are a couple of UI libraries that get compiled into the JavaScript bundle. There's a little bit to see in the configuration that's being used. It shows all the extensions that it has added. It shows all the functional hiccup components. So these are like additional tags that I can use on top of normal hiccup. I can see all the pages I have. Each page is basically an entry point that I can enter via a route. I can have the services, so each services can respond. That's like a Clojure function that returns some sort of data. So we should see here my the fortune cookie services, and then I have here a list of bindings. This is basically Clojure script variables, and we can see how they are represented in the SCI part. The whole thing is the modules can be configured so that they are lazy loading. So not everything is loaded on startup, which I think is quite important since the Clojure script and the SCI interpreter is already quite big. There is a theme loader where all the components can change the themes. And I made some, where are we here? Let's take perhaps that. There is a little module that can compile Clojure namespaces. So let's take, for example, this one here. Where do we have it? This comes from the demos. So in the config, you can list namespaces that should be compiled and then shown as notebooks, essentially. Yeah, that's. There's also some Clojure script REPL, but that's the part I'm still working on. And it's possible to send any kind of expressions from Clojure via a Scratchpad interface. So I could send entire web pages to a Scratchpad viewer and develop like that. Yeah, that's from my part.
Thank you so much. Maybe you could stop sharing the screen if comfortable.
Yeah. If I would find where stop share. Yeah.
Fantastic. Yeah, and all these topics deserve much more time. And of course, we will be happy to organize a dedicated session for any of these as much as the authors like. Thank you all for these amazing presentations. And I think, is there anybody else who may wish to show anything of this kind of visual tools? Because I know there are a few people who may be working on that. So could be nice if anybody wishes to demonstrate anything. And otherwise, we could have, I think, like 3 minutes break and then have a discussion about what we have seen now. And in this discussion, I think we are hoping mostly to create some dialogue across different tools so that we can hopefully create these layers of compatibility we are hoping for. But first, maybe let us have 3 minutes and then rejoin. So see you in a moment. Hello again, we are after a short break and we will have now a short discussion of the visual tools topic. And we have here the, I think most of the 7 presenters who were presenting these topics. And I think it could be nice to start with maybe actually if anybody who was presenting would like to add a few sentences about kind of retrospective look into all this, it would be nice if any of you wish to say anything more. What do you think?
Yeah, I mean, I can echo your, the one thing I'll say is just to echo your desire to see conversation around how we can all collaborate with our tools and interoperate with our tools more. I mean, I think for me, one of the goals is really to see, and to put it a little more concretely, like it's been amazing to see today all of these different projects, you know, using Vega and Vega Lite in different ways, because I feel like it kind of makes it almost an extension of kind of the data vocabulary that we have in the Clojure sphere, right? We know, like between hiccup as a notation for HTML, that's just this simple data thing that we can all kind of use as a common vocabulary, a common vernacular. We've like now kind of, we're moving in that direction with so much adoption of Vega and Vega Lite. So it's yeah, it's really cool to see that, and I echo your desire to see more discussion around how we can make all these tools interoperate as much as possible, so that people in the Clojure system just feel like they have this sort of superhuman strength to like build all this stuff and have it, you know, be able to use it in different contexts and stuff. I think that's, yeah, I think it's a pretty cool vision.
Great. Yeah, any other comments of the people who were presenting? No? Then otherwise, maybe we could do like a short round of questions of anybody who may wish to ask anybody who was presenting about those different tools. I
have a question.
Yeah.
This is for, I think, Florian, and maybe also you, Daniel. Looking at the, what was it called, Goldly? I know that you have talked about those tools in that ecosystem being useful in sort of modular ways for Notespace. I was wondering if you could give like a high level description of what those component, like module or components are and how they fit together. If that makes sense. Like, yeah.
What components of the Pink Gorilla ecosystem?
Yeah, yes, sorry that I got the name wrong, yeah. Yes, the Pink Gorilla ecosystem.
Yeah. What do you think, Florian? Would it make sense? Is it something that could be described briefly, or does it need like a dedicated meeting where we can have the landscape of the Pink Gorilla project? Oh, I'm not sure if Florian is hearing us.
I'm sorry, I had.
Oh, hey, yeah.
So the question is, where are how should we say, the common libraries where we should do things together? That's the question, right?
Or maybe first, I think the question was about the different components of the stack you're building. If you could kind of name them, if it makes sense.
Yeah.
right?
Yeah, it might be too big a question, but my question was just sort of like super high level. What are the components of that ecosystem, the Pink-REL ecosystem, and what do they, how do they fit together?
So there is Weebly, which is basically just let's say a wrapper around Shadow CLJS to build Clojure script. And what it does, it helps you in a way that you do not have to specify a complicated configuration Shadow CLJS, which can be quite a pain to set up, especially when you have advanced compilation, lazy loading, when you want to have conditionals, where you want to have certain dev tools included in one build and not the other, and so on. So that's the Weebly. Goldly has two things. First of all, it has a component registry system. So basically what it does is any libraries that are in your class path, the resources are scanned for a Goldly extension.eden file. And they are then basically put together and used in case you want to build the entire thing from scratch. Certain namespaces will be added and so on. In case you're just running it, certain services will be started when you start it. And the other part of Goldly is that it adds to the front end bundle the SCI interpreter, and it adds that with its component system. So each component can define exactly which functions you do want to have available in the SCI Clojure script. So that's the Goldly.
Could you mention what SCI is for those who haven't?
I'm sorry, SCI is the small Clojure interpreter, which is a very convenient way to do Clojure code that is running in the browser. So SCI is converting Clojure code to JavaScript. The next component is modular, which is basically taking care of persistence or serialization of the communication wherever it is, whether it's in a RESTful GET or POST call, whether it's a WebSocket, whether it's on writing it to disk, and it is extending the predefined Clojure data types that can be serialized by adding more. An example are all these dates that normally do not work. Modular also comes with a configuration of a library called cprop that helps to basically configure a complex system and put together all the parameters. It's like a config management tool. And the last tool is reval, which is a library that basically allows you to compile a namespace, and so basically you would eval all the expressions in the namespace, and then you save the notebook as an eden file, with the added benefit that all the eval results can be are converted if they match certain rules to hiccup visualizations. And the last thing what it does is it manages all the resources that you want to have in a notebook. Let's say an image that is the output of what was the name of the Clojure library from Tomasz, the CLJ plot. So you have it in the same folder as the rest, but it could be also like arrow files or any other kind of data. And what I use reval for is that I define a list of namespaces that I want to have converted to notebooks, and all of them are then browsable in the web UI.
Thank you. That's super helpful to get that big picture. Yeah.
Great. So, yeah, maybe does anybody of the does anybody have any questions? Sorry.
Yeah, this is John here. I have a question. Can you hear me?
Hi.
Yeah, I have a question for John regarding Saite. I think it was pronounced.
Saite.
Saite. Okay. That was, you mentioned some stuff was shareable. Wondering what that means, and is it shareable? Are some subsets of things shareable to some web client, or does the place you're sharing it to, do they have to have a full installation as well?
I'm not totally sure I understand the question. If you're asking whether or not you can publish static versions of the thing, that is not yet there. That's been asked for as well by various people in the labs, but yeah, static stuff isn't actually available.
I think that would be neat, just for like blogging, having static blog or what have you. But so you did mention sharing, I think. What does sharing mean in Saite right now?
Well, I guess, okay. What it means is, like in one of those several of those examples, as far as they go, anybody can pull up their own personalized version of one of those dashboards or documents or whatever, and fool around with it using their own data. For example, that's probably the most what I'm talking about. So all of this is shareable in the sense that it's not necessarily the case that it's just a desktop thing that nobody else can get at.
Gotcha.
Actually, I guess the other thing is that if you, all of this stuff is, when it saves stuff, it's all just text. It's all just complete text. And if you stick it out, stick one of these saved documents out on the web, you have an installed version of this thing. You can just pull it right up.
Gotcha. Okay, that makes sense.
I thought I should mention, John, that kind of goal that I think you're talking about of, being able to have a static website, like a blog, scientific blog or something, that is one of the explicit goals of Oz, which again, just to kind of reiterate this point, it's been kind of a challenge to get people to get their heads around what Oz is, because it kind of does so many things. So still searching for the language to, get that across more cleanly.
Yeah, I was wondering about the rest of these tools that we went over to what their story was for static export, because there's been some neat static blogging tools made recently, and it'd be cool to just tie that into, I guess you call it these live namespaces or something, and having just a live blog.
Yeah, exactly what this is actually. I mean, I can kind of demo this real quick.
Maybe some other time, because
okay.
Yeah, sorry for.
Oh yeah, sure.
Yeah,
I was just gonna do it shortly, but basically, in fact, what you were looking at literally is creating static output.
Gotcha.
So what you do with Oz is there's an Oz build function, and you pass a series of specifications that describe what's the input data, or what are the input files, and where does the output go. And it could be a single file, or it could be a directory of files, which we'll just respect the directory structure there, or substructure. And you can customize how stuff in one of these build specifications is going to get built from stuff in another. So one of the things that I found really lacking in a lot of static site generation frameworks is that they'd make a lot of decisions, like specifically around how like blog posts are going to be handled. Like that was always this sort of separate thing, but then there was never as much kind of customization about like, how would you make one kind of part of the site look different from another based on, what the purpose was or whatever. And this is one of the things that solves. So you can put all of your blog posts in one directory, create one build specification for, this is how I want to render these. I want to display the title that's attached to the content as metadata, either on like the Clojure namespace symbol, or just as like markdown metadata at the top, like you would do with Jekyll. And then, so yeah, you'd want to display the title probably automatically in keywords and stuff like that. But you'd also might want to display like a sidebar with links to other, recent blog posts. But you might not want that stuff on like your main page, or might go the other way, right? Like you can do any sort of combination you want. But the point is that by separating the templates and various compile options per, build description, which you can have multiple of, you have a lot of control over how you build different parts of the site. And you can specifically say, like, I want to live watch the content that's coming out of this particular just input directory, but I don't want to watch the stuff that's coming out of this other one. So yeah, you have a lot of flexibility. Like right now, what we were looking at before, I didn't have time to show it, but it was actually compiling a static HTML file as a result of that. And it does, at least if everything's set up properly and you have the right options, or not conflicting options, I should say, then it will compile a static image, either as SVG or as PNG, into the HTML. So when we say static, it's like it's a little confusing, right? Because it's actually compiling a static image into the document, but the HTML is such that if it's like a live, JavaScript enabled environment, then the JavaScript will take over and replace the image with the actual visualization once it's ready. So this makes it great for if you're using downstream tools to convert into PDF, or for later when we directly support PDF, which I'm working on right now. But also just for like, if you're sharing a document and you know that like it's a weird case example, but like in Dropbox, if you share an HTML file, it'll actually show a preview, but of course it won't run any JavaScript. So you can share one of these HTML files with someone in Dropbox, and all the visualizations will show up. It might look a little weird because it's not doing the styling and stuff, but like, it's at least better than people getting this preview and realizing like, oh crap, like none of the visualizations were there. They probably had no idea.
Maybe maybe let us try to be brief. Sorry for this, because there is so much. A few people wish to be asking questions. So, Christopher, would you kind of conclude this if you could?
Oh yeah, I was actually done. But
oh yeah.
Unless anyone had more on that, I actually had a question for you, Daniel.
So I think Lukasz has a question, and then you could. Yeah, thanks. Sure. Sorry.
Yeah, sorry. I was thinking like the part why we're talking all together was like we have all the tools have some things in common and some goals that they don't share. And it would be interesting to find like those things that we can build together so that not everybody has to build the same thing like 10 times. Like I've been bothering Chris B, the portal developer, for like, I don't know, a month now, to get interaction into the Vega view so that I can do things on that. I've seen that Oz just built it in last month or something, that you can get the view and run functions on that. And everybody has its own implementation, and then you need like some way to get the options in there, and everybody's gonna pick a different name for the option and so on. So when I write my specification in one, it's not gonna work on the other and so on. And in the end, it's all gonna be like the same. You want some way to get to the view of the Vega, and you want some way to like execute something on that. If it's JavaScript, well, nice. If it's not, it's fine. But like, it would be nice if we could all like agree on at least like some common bottom line. Like, okay, we have like the Vega specification, and there's one extra object on there that I can put some methods on that can get the view or something. And everybody basically does the same thing. And the other thing that we all share kind of is like a way to go from data to like a visualization of that. Like in Portal, I can say, okay, show me that like, I don't know, as a table or so whatever. And I can do the same thing in Clerk and in Oz and in whatever. But if I like I don't know, the visualization of Portal for, I don't know, tables better than the one from Oz, I can't just take it from Portal and show it in Oz. At least not yet. But underneath, it's all the same thing. It's just saying, okay, what's the predicate to decide, can this be shown as that? And if it is, here's a bit of Clojure script code to just make it work. And all those visualizations, basically, they're not the same, but like the structure underneath is the same. And we could all share that as well. So that if somebody builds a nice visualization for, I don't know, tables, like I said, we can use the same one across all things. If we just come up with like, I don't know, 3 keywords in a map, so that you know, okay, the predicate is always pred, and the function is always, I don't know, render function and so on. Yeah.
Perfect. So that is so wonderful. And I want to suggest a few things for both for the remaining 9 minutes that we have of this session and for the future. So for the future, I hope maybe a few of us will like to meet and have a long meeting of brainstorming just about that, just about learning the current situation and thinking what could be done, at least for a few of the tools. And for this session, except for one thing you were going to comment, Christopher, maybe what we could do is try to raise some ideas of specific points where some compatibility could be reached. So, for example, Christopher Small had this idea of metadata for Markdown. Why wouldn't I use that too, right? So maybe we could just very briefly raise a few of these so that we can think about it for the future. And let us try to be kind of brief in the coming minutes. And Christopher, you were going to say something, and then we can do that.
Sure, if I can, well, yeah, if I can answer. So the thing I was going to ask you, maybe this is quick, maybe it's not. If not, we can talk about it later. But I was really interested in seeing if I understood correctly. I mean, it looked like you were evaluating forms in a Clojure file, but like evaluating with your REPL, and that they would update in the in the visualization. But it didn't look like you were just sort of like whatever was getting evaluated was getting sent and like appended to the end, right? Like it has a sense of structure. And so how is it, you're not saving the file. How are you getting, like when you evaluate something, how are you identifying like what block on the front end needs to get updated?
Yeah, great. So the answer is not that it is not always possible.
Okay, yeah.
Yeah.
Yeah, and this is something I wrestled with too. So I was just curious to see, yeah.
And then after that, let us just discuss it some other time, because
it
is a challenge.
Yeah.
Yeah. Thank you.
Can I also add one thing to what Lucas was asking, since I'm already here? I think that the thing you brought up about, kind of common pattern for options. One thing that comes to mind there is the way that Oz's components work is both like on the reagent side and kind of statically, is that if you have like a Vega, this may not work for all of our approaches, but like if you have a Vega or Vega-Lite block, the first argument is treated as the spec, the Vega or Vega-Lite specification, and then the second is treated as options, which kind of maps the Vega embed API. And I think that that's a place where, at least in my own code, I've tried to, everywhere that it kind of looks like, okay, here I'm doing a Vega thing, I always want there to be an optional second argument for these options for the embed. So that's maybe a place that we could kind of converge on to say like, okay, where possible, we should all try to kind of do things this way, respect the Vega conventions for this options mapping, and maybe talk about what what other points of commonality we want to have there.
Yeah. Could I ask possibly Vlad and Chris Portal, because maybe you may have some comments about that.
Yeah, I think it'd be really cool if we could kind of intermix our components, if we had some type of like registry, or I think the thing that makes it a bit more complicated is with like Clojure script, you have to have a build, and then we have to make sure that we're all using the same versions, and that like, I think it's I would say extensibility is easier in a Clojure runtime than it is in a Clojure script runtime. But I think it would be really interesting if we could figure out a way to kind of be able to take your Clojure script components from this library and this Clojure script components from this library and kind of piece them together and just let users use them. And then as implementers, we kind of have like a standard API of like, okay, you give me data and I'll like, I don't know, I'm assuming we're all using reagent kind of on the front end mostly. So like the ability to interoperate is just like, I'll give you a React component or reagent component and you render that. And then they can like go back and forth, I guess. That'd be really cool. I don't know how we would do that though. But then the advantage then is that you could specify any little behavior you wanted, right? Like, oh, on hover, I want to do this. On click, I want to do this. Or on whatever I want to do that. But yeah, I think having like getting the code in the browser is one challenge, and then the other challenge is like, what's the API look like from the implementer's perspective? So I don't know what other people are thinking, but does Oz support like customizing, like having a custom view, like adding your own behaviors? Okay, so how do you manage the Clojure scripts?
Yeah, so that's the part that I'm still kind of working on. Yeah, and you've nailed it on the head, right? Like that's actually the challenge. So yeah, right now you can, if you're using the front end, I mean, you basically right now have to compile your own app to use it on the live view kind of side. But like for the for compiling static stuff, you basically plug in a what are they called? Like I'm trying to remember. I can't remember what the option is called, but basically you plug in a map of keys of tags basically in your hiccup that are going to get processed by some function. Compiler functions, I think, is what they're called. Maybe.
Yeah, and I think what we saw briefly in Goldly was that this idea of registry, of having specific symbols bound to specific components, is something that could be made systematic. And what Chris Portal you're suggesting is maybe to kind of standardize that, maybe to kind of communicate this in some way. Vlad, do you have anything any thought about anything that we have seen?
Yes, I just wanted to comment that reveal by using CLGFX like has a keyword argument approach instead of positional. So it can't really work with the idea that like to a Vega component, the first argument is a spec and the second is an options, because there is no first and second argument. There are keywords.
Right, yeah. I thought about that as I was saying. I was like, actually, yeah, that's not going to work for all cases, right? Yeah. But where that is the pattern, you know, those are the kinds of things that we can converge on. And maybe for where it's more of a metadata attachment, then, you know, we can come up with a separate set of patterns there.
Yeah, that's what I wanted to add.
Yeah, so and then there are those collections, existing collections of widgets or viewers or whatever they're called. And I think both Oz and Goldly and Portal and Reveal, all of them actually, except for Notespace, which is kind of using the others, they all have those collections which are growing. Then there is this question, how to help them grow, how to help the community contribute to them. And then I think, Chris Portal, you had some comments about how we could approach that, maybe like at least by sharing code, as you said, right, in your meetup.
Yeah. I think like a first approach would be like having a shared repository, because then the assumption is that everyone does the builds their own. So you're still like producing, you know, like the Portal app or the Oz app or whatever. It's still an independent build chain, which doesn't give the users flexibility to kind of piece things together themselves, which would be, I think, the ideal is to have the user be like, I want this and not that, but that, and kind of put it all together. And it's like, and make that really easy. That's the ideal, right?
I mean, I think what has to happen is every category of UI visualization components have to be in their own GitHub repository, and I think there need to be only two assumptions. One of them is to use React, and the other one is to have a convention for CSS, which is something that most UI render components require to be there before you can call them, because if you do it the other way around, most of them would look fucked up. And I say this because I think it's mostly about the complexity to understand how these components work, right? Most of these components are very simple in the way that there is an NPM library that does something, right? And we just need to do a little bit conversion to make it more Clojure friendly. But typically there are all kinds of very strange build things that need to be considered. So you do not want to understand how components that you would never use work to make changes to one component. And it is very cheap to make a new GitHub project for just one function, right? This is possible. So that I think is important, and it is important because we really want high quality components, right? We want, let's say, components that can have different themes. We want to have components that have different sizes, right? Like a user specified size, as big as possible, in a grid, whatever. And so far, I have not seen anyone doing that, right? We have like very amateuristic components, and there is nothing there that goes to a really high quality. Now,
we have to be brief. Apologies for that. Yeah, I didn't want to stop
I'm sorry,
you.
make it short. One more sentence. So the other thing, what I think is essential, it is quite, I see a lot of repetition of setting up build systems for ClojureScript. And so I think it's important to have a build system where you can compile a component and have something that gives you a website where you can play around with just this one component. I made this with Awb99 and Goldly, but there are other ways also. So that is the if we want to move more in this direction, this will be another choice.
Great. If it is okay, then I would ask all the presenters to maybe say one or two sentences before we conclude, if it is okay with you. And then we'll take a short break before the next session. And we need to meet again, of course.
Thanks for inviting me.
Well, let me say something perhaps. I think with Clojure, the potential is there to build a mathematical, statistical data mining platform that is superior to commercial tools like Mathematica or others. And the only thing what it would require to come together and build like this one tool, and not to have 100 different tools that are all their own islands.
Any comment, Chris Small? Any like concluding sentence?
Yeah, I guess it seems like we're all thinking about similar things. So yeah, let's think about how we can collaborate better. I mean, I know for me, for Oz, like one of my kind of longer range goals now that's kind of more clearly within sight, now that I just understand where things are going, is to start pulling apart some of these pieces so that it is clear to see, you know, if I just want this functionality, I'll just use this component, et cetera. It's been nice to keep everything in one project, but yeah, that may be coming to an end. And so I think in that process, yeah, looking at how pieces can be shared and reused will be really nice.
Vlad, do you have anything you may wish to say?
Since everything UI seems to be converging on web and HTML, I just want to sort of point out that Reveal is not based on web browser. Like it can embed a web browser, but the one it is able to embed is some sort of a WebKit fork, which is unfortunately not everything works there. So like Vegalite's visualizations can work without problems, but some other can't. For example, I just tried embedding Portal UI in a Reveal sticker window, and I could like launch the UI, but when I was submitting values, there were errors displayed in the UI. So I just hope that everything will work out fine, and I'll be able to use those components. But be ready for I don't know, bug reports from weird WebKit forks.
Chris Potal, sorry for asking only now. Could you teach me to say your name?
Oh, Chris, it's Badahdah, which I usually go by Chris B. It's like enough of
yeah.
Because there always tends to be another Chris, so Chris is not sufficient to disambiguate. But
yeah, so Chris Badahdah, could you conclude as the last one as well?
I'm really excited with all the visual tools that we have now in Clojure, because I feel like Clojure is just a really good language because systems tend to be very data oriented, and so having tools that know that I think is really powerful. And I like that there's like all these ideas. And I think that the fact that we're having this discussion and we're saying we need better interoperability with each other, I think is like a good sign, because I think like that's going to be the future I want, where we can all just like take stuff here and solve like our problems, because we're all gonna have different problems. There's not going to be one tool that's gonna be right for everyone, but being able to kind of make your tool based out like this person, I need their thing and I need their thing, putting them together, I think that's going to be really nice. Because that's what you do as a software developer, right? You grab this library and this library, you put it in it, and you combine it in a way that is novel, and you solve your problem. I feel like that's what I want, that flexibility with our data visualization tools. So I'm really excited.
Beautiful way to conclude.